Okay, so we just looked at this example here of x plus 1 and saw that the limit as x approaches 1 of f of x is 2. Now, many of you may be thinking, okay, but the function was x plus 1. Of course, if I get to x of 1 and I add 1 to 1, that's 2. But that's not exactly what's going on here. So the key point here is that the value of the limit as x approaches a does not depend on what is actually happening at x equals a. So really the fact that the limit was 2 had nothing to do with the fact that there is a point 1, 2. In order to clear this up, let's look at these three functions, which are very similar looking functions, but they're different. Okay, so let's take the first one here. So this is going to be f of x. So f of x is x plus 1. That's the function we were just looking at. G of x, on the other hand, is going to be x squared minus 1 over x minus 1. Now, you know that x squared minus 1 factors into x plus 1, x minus 1. And so you have x minus 1 on top and bottom. Now that's not the same as the first function, f of x, not exactly. It's the same except there is a hole at x equals 1 because the function's not defined there. Okay, so that's another version. Okay, and then the final one is h of x. All right, so for h of x, it's a lot like the previous one. Instead of having a hole, though, well, in addition to having the hole, we also have the function defined at x equals 1 to be 1. All right, so that's what we can see in the piecewise definition down here. It's x squared minus 1 over x minus 1 when x is not equal to 1. But when x is equal to 1, the value of the function is 1. Okay, hence putting that point right there. Okay, so let's look at how this affects the limit if it does. All right, we saw previously that if we approach in f of x, if we approach 1, then the function values approach 2. And we reasoned then that the limit of f of x as x approaches 1 is 2. Now let's look at g. As you approach 1 in x, notice that the values of g approach 2. They still approach 2 because we have to act as if there's some invisible line here at 1 that we can't see what's going on at 1. So we don't see that hole. We just see the fact that these values are approaching 2 as I get closer and closer to x equals 1. So this limit is 2. And finally, in h of x, as we approach x of 1, in the function, we approach values in y of 2. Even though actually at x equals 1, the value of the function is 1. But the limit doesn't care about that. The limit says as we approach x values near 1, we approach 2 in y, regardless of the fact that there is this point at 1, 1. So the limit, again, does not care. Each of these has a limit of 2, regardless of what is actually going on at 1. And I'll say this repeatedly, the limit doesn't care what's actually happening at that point. We'll bring that point in later when we start to talk about continuity, but for now, the limit doesn't care. So with all these examples that we've looked at, we've said approach x equals 1. We haven't been really clear about what we mean approaching it. Are we talking about from bigger or smaller? In these examples, it has all been the same, so it hasn't really mattered. So we need to take a closer look at what we mean by approaching some x equals a. So we're going to have to break it down into one-sided limits. So we're going to talk about coming from each side. So we're going to talk about coming from the right and the left of a. So the limit, so reading right here, the limit as x approaches a from the right. So we read this plus as from the right. Basically, we're thinking of if you had zeroed this thing out. So we're talking about at 0, the numbers to the right of 0 would be positive, the numbers to the left would be negative. So we've come up with a notation that mimics that. So the limit as x approaches a from the right of f of x, that would be the limit from the right. In other words, that would be what is ever happening to the function as you approach a from the right. So you'd be talking about what is happening up here, where are the values going as I approach from the right. Whereas your limit from the left, so the limit as x approaches a from the left of f of x would be what you would be looking at if you approached a that way, and in other words, if you were on the function going that way. All right, so we've broken it down into the two aspects, from the right and from the left, because those are the only two ways we can approach a. Okay, so how does this relate? Now we have one-sided limits, and we want to talk about the whole limit from before. Well, we have a theorem. It says, let f be a function, and let a and l be real numbers. The limit of f of x as x approaches a is L, written limit x approaches a of f of x equals L, if, so this is not a misspelling of if, this is if and only if, that's a mathematician's shorthand for if and only if, which means they're equivalent. It's something you might learn in a logic course. I'm not going to go into that right now, but that's a stronger than just saying if. If and only if the limit as x approaches a from the left of f of x is L, and the limit as x approaches a from the right of f of x equals L. What are we really saying? We're saying that you get the limit, you can think of it as the whole limit, but we just say limit. The limit, you get a limit at f of x of L if both the left and the right limits exist and they're equal to the same value. So the key here is both one-sided limits exist and are equal. Okay, so that's the two things we're going to be looking at. Now, I understand we haven't really talked about why they might not exist yet, but we'll get into that. Basically, at this point, we're saying if they're both equal to some L, some real number, then that's how you could determine that the limit exists. Now, there can be cases where you don't have both sides. So if we look at something like the square root of x, obviously the square root of x does not have the negative numbers as part of its domain. So the only way that you can approach 0 is to come from the right. So we could say the limit as x approaches 0 from the right of the square root of x and ask that question. Now it appears that as you approach from the right of 0, that the function also heads to 0, and so we can say the limit as x approaches 0 from the right of square root of x is 0, but there's no way for us to say anything about from the other side because there's no function there. So that can happen. You can only have one side, and that's not really a problem. That's just how we deal with it.